So in our previous discussion, we have discussed what are fuel cells and also the construction and working of methanol oxygen fuel cells. We have seen how fuel cells are classified, right? So fuel cells are classified based on their electrolyte used. So if the electrolyte used is acid, they are called as acid fuel cells. If electrolyte used is base, they are called as alkaline fuel cells. And if electrolyte used as solid, it's called as solid fuel cells or solid oxide fuel cells. So today let us discuss the construction and working of solid oxide fuel cells. Let us take an example of hydrogen oxygen fuel cell where the electrolyte used is a solid oxide. So how the construction is and how it will function, let us discuss. So here the electrodes are made up of. So here, as usual, both the solid oxide fuel cell or any fuel cell contains an anode and cathode. So the anode is usually made up of porous cement of nickel metal, which is of yttria doped with zirconia. So it is made up of nickel, is coated with yttria doped with zirconia. That is your anode. Whereas your cathode is nothing but strontium, which is doped with lanthanum magnite. So your anode is nickel and cathode is strontium. So your anode is coated with yttria doped with zirconia, whereas cathode is coated with lanthanum magnite. So in between these both we have electrolyte. The electrolyte the electrolyte is the solid electrolyte. The electrolyte used here is a solid state. It is yttria doped with zirconia. The electrolyte used here is yttria doped with zirconia. So here the fuel injected here is hydrogen. At the anode, the active species at anode is hydrogen, and the active species at cathode is oxygen. So hydrogen will be let through the anode inlet and oxygen will be let through the cathode inlet. So here the redox reactions takes place. Okay, so once the redox reactions, you can see here the hydrogen is left over here and the oxygen is left over here. So hydrogen undergoes oxidation, whereas oxygen undergoes reduction. So redox reaction occurs and electric current will be liberated. So until we are supplying hydrogen towards anode and oxygen towards cathode, we can continuously obtain the electric current. Once we stop supply of hydrogen or oxygen at either at anode or cathode, we can no more withdraw the current. So the products formed are water. So the water will be removed continuously from the anodic chamber, and the unused gases, maybe hydrogen or gases, so hydrogen or oxygen will be removed continuously from the cathode. So I will repeat again. So the anode used here is nickel coated with yttria doped zirconia, whereas cathode is strontium doped with lanthanum magnite. An electrolyte used here is solid state of yttria doped with zirconia. Since it's a solid state, it is called as solid oxide fuel cell. So as discussed, these are the anode and this is cathode and this is the electrolyte used. Let us see the electrode reactions occurring at anode and cathode. So at anode, hydrogen undergoes oxidation to give you water and liberates two electrons. This is O2 minus. In presence of O2 minus, hydrogen undergoes oxidation to liberate water and two electrons. So at cathode, oxygen undergoes reduction, accepting these two electrons liberated at anode to form O2 minus. So this H2 hydrogen and oxygen will give you water. So the product which is formed is only water. The water formed will be continuously withdrawn from the cathodic site. Okay. So there is a small video which shows the functioning of solid oxide fuel cell. Let's see.
A solid oxide fuel cell is an electrochemical device that produces electrical energy by oxidizing fuel. This system itself consists of a porous anode and cathode that are separated by an ion-conductive solid electrolyte. In this device, the fuel is oxidized at the anode, while the reduction of oxygen takes place at the cathode. These reactions are possible if the electrons participating in this process can move from the anode to cathode, but the only way to do that is to use an outer circuit. And that's where we can harness the electrical energy. For more science videos like this, hit the subscribe button and check out the Captain Corrosion YouTube channel.
So let us see the advantages of solid oxide fuel cells. So the efficiency of the fuel cell is around 60%. So however, during the fuel cell, when it is functioning, what happens here? So when the fuel cell functions,
as
when
solid
the
oxide.
fuel cell is functioning over here, so the energy will be liberated over here, and simultaneously the heat will be liberated. Almost 40% of heat will be liberated over here. So that heat can be utilized. So whatever heat is liberated over here, that heat can also be utilized. If that heat is utilized for some other purpose, the efficiency will be can be increased to 85%. This is one of the advantage of the fuel cells. So the solid oxide fuel cells, the output will be around 100 kilowatt of electricity. So there are some other limitations also, some other advantages and limitations. Let us see. So it is the fuel with the minimal or no processing can be induced the anode. I'll just show you in our next slide what are the other gases which can be fed to anode instead of hydrogen. So without processing, you can use any other gas or natural gas for anode act as an active species. So no, you cannot, I mean, without using any catalyst, the fuel cell will function. So the operating temperature is around 980 degrees Celsius or 1800 degree Fahrenheit. So this is the waste heat that is generated. This waste heat can be utilized. So how will we utilize this waste heat? We'll discuss in our next discussion. Okay, so only challenges or limitations is not to start, it's a low start. So we are supposed to supply some energy in order to start. So high temperature, so since it's liberating a high amount of temperature, that is 1800 degree Fahrenheit or 1900 degree Fahrenheit as operating temperature. So the temperature should be balanced at the plant. This is the major issue. So what are the, as I told, as we discussed here, so the operating temperature, I mean no able to use natural gas as fuel with minimal or no processing. So what are the other active species which can be used at anode other than hydrogen? Let us discuss. So we get waste from forests, we get kitchen waste, we get animal waste, we get agricultural waste, we get solid waste from garbage, we get poultry waste, we get sewage waste. So all these can be into gasifier. So whatever gas we obtain there, so that biogas there, it undergoes their degradation, right? So all these are organic waste, whether it is a poultry waste or forest waste. What is forest waste? Those are leaves. Once again biodegradable. Kitchen waste is once again biodegradable. Animal waste biodegradable. Agricultural waste biodegradable. Solid waste biodegradable. Poultry waste, poultry, kitchen poultry, that is, I mean that's also biodegradable. Sewage waste biodegradable. So all these would waste undergoes biodegradation, maybe aerobic or anaerobic degradation, and generates gas. So that gas can be directly fed towards the anode without any processing. So that gas also can directly fed at anode, whereas cathodic active species is oxygen only. So any gas other than hydrogen, it is not necessarily supposed to feed only hydrogen. Other than hydrogen, you can feed any other gas, biogas, towards the anode. It will act as the active species and it will function, and whatever energy is liberated here, that electrical energy can be used for various purposes. It can be used here for transportation. It is used in portable devices. The applications of solid oxide fuel cells, that is the solid oxide fuel cells can be used in transportation. It is used in portable devices like laptops. It is used in stationary applications. It is used in housewarming purpose. It's used in ships. So as we discussed, it liberates around 1800 degree Fahrenheit or 980 degrees Celsius heat, right? So that heat is completely liberated here. That heat is waste, so we are not supposed to waste that heat. So that heat is used here to run heat turbines. So through heat turbines, electricity is generated. So once again, that electricity is used for supplying for industries, for commercial purpose or household purpose. So heat is also not waste. So because of this, the efficiency of this solid oxide fuel cells is 85%. Right. So but generally it is just 60%. So because we're utilizing the heat liberated by this solid oxide fuel cells, the efficiency were increasing to 85%. So as discussed, the applications it is used in, we can use it in transportation, it can be used in portable devices. I mean, applications means you cannot use directly the fuel cell in the transportation purpose, because the energy, in order to maintain that temperature, it is a big task, right? But the energy liberated from that can be used for transportation purpose, for portable devices, stationary, and for housewarming, especially in Western countries. But in ships, you can use the fuel cell as a major source of energy. Thank you. So in our next discussion, we'll see what are the other alternate sources of energy. Thank you.